everyone. Welcome to this session on time response analysis in first and second order system response. In this video, we will explore how first order system respond to different inputs and understand their practical significance. So let's recall the last class topic, that is time response analysis in control system. So in this topic, we discussed about the transient response and steady state response of the system, and the time response analysis with various time specifications and parameters. Now, today's topics for discussion is introduction to first and second order system response, fundamentals of first order system, impulse response of first order system, step response, and RC and RL circuits of first order systems. Let's move on to the empathize part of this DT. Empathize part, why this topic is important. And first order system response plays a key role in many real world applications such as signal processing in communication systems, transient behavior in power electronics, switching circuits in digital electronics. And if not properly analyzed, it can lead to signal distortion in transmission, system instability and oscillations, power efficiency in circuits. And we go for need for this solution. So some limitations of existing methods gives the classical analysis requires complex calculations. Manual techniques gives a time consuming for multiple inputs and approximations errors in non-ideal conditions. Now let's move on to the fundamentals of first order system. This shows the DT defining stage of this fundamentals. Now let's see about the definition of first order system. A first order system is defined as a system with a single energy storage element. It is characterized by the first order differential equation and it has only one pole in transfer function. For examples, RC and RL circuits. The transfer function we defined as G of S is equal to K divided by Ts plus 1. In this, K represented as a system gain and T represented as the time constant. Next one is the impulse response of first order systems. The impulse response is expressed in mathematical derivation. C of S is equal to G of S into R of S. So we know that the gain is 1 divided by Ts plus 1 and into the R of S. The impulse response input of unit impulse is 1. So we multiplied with 1. So that is equal to 1 divided by Ts plus 1. The input R of t is equal to del of t for unit impulse. So if we are taking Laplace transform, R of S is equal to 1. This shows the partial fraction of this equation, and this is the inverse transform of this equation. The response of this first order system represented as like this. And next one is the step response of first order system. The step response of first order system is represented as the mathematical derivation C of S is equal to G of S into R of S. The G of S we know that 1 divided by Ts plus 1. Here the R of S means this represents the unit step signal. So we noted that R of t is equal to U of t for representation of unit step signal. If we are taking Laplace transform on this, R of S is equal to 1 by S. So we substitute the R of S value into 1 by Ts plus 1 into 1 by S. So the final equation is 1 by S into Ts plus 1. This shows the partial fraction of this equation and this represents the inverse transform of this equation. This graph shows the step response of the first order system in x-axis time and y-axis represents the magnitude response of the particular system. Now let us see the RC and RL circuits as first order systems. If we consider the RC circuit, the transfer function represented as G of S is equal to 1 divided by RCS plus 1. So time constant is t, that is equal to RC. So step response is V of t and impulse response is Vc of t is represented here. And if we come to the RL circuit analysis, the transfer function represents the G of S is equal to 1 divided by L by R of S plus 1. So the time constant here represented as the T is equal to L by R. This shows the step response of the system and impulse response of the system. The graph shows the first one represents the RC circuit and second one gives the output response of the RL circuit. Next, the activity session, and let's summarize the time response analysis of first and second order system. The first order system have a single energy element. Impulse response shows the exponential decay and step response shows gradual rise to steady state. RC and RL circuits are practical examples. So understanding these responses is essential for system design and analysis. Thank you.